Okay, I'm going to do number 45 here. So when you put money in the bank gives you interest to take your money and use it, and they loan it to other people and make money off it their own way. And so here's a bank that will give you 7% interest. And compounded monthly means the 7% is per year, but it means every month they give you a twelfth of that. So it means you get interest every month, and then of course after that you have more money in the bank, so you make more money because you have more money in the bank. So you're getting interest on your interest. So here's how we solve this problem. We want to know how long it takes $600 to double if it's invested at 7% interest compounded monthly. So here's what these numbers mean. This 600 is P. That's the amount we put in the bank. Then we have 1 plus, and our R is 7%, 0.07. And our monthly is the number of periods that we have it in the bank. I'm sorry, how often it compounds. Okay? And then N, again, is the number of compounds. So that's a 12 here in the exponent as well. And T is what we're looking for. How long does it take? So that's a variable. And then we want it to double, right? So if we want it to double, it means we started with 600 and we want 1200. Okay? And now we have an equation that has just one variable in it. So we can solve that equation eventually using logs. Okay, so that's what we're going to do. So I'll leave that to you because that's kind of like what we've been doing. Okay, it's a calculator question. Here's the second question. And I'm going to do number 41. And this time we have this formula that in general, you'll see this a lot, is y equals y sub 0 e to the kt. And it's a place where e occurs naturally. Natural log. So here, this 0.043t, this 0.043 is sort of the, kind of like the interest in the other problem, but it's unique to this species and how it grows. So our general formula here is y equals y sub 0 e to the 0.043t. And we may see ways to figure that out given other information. But now we want to answer the question. So if the size of the current population is 83, okay, so the current population is y sub 0, that's 83. How many should there be in 5 years? Okay, so that means we're going to say e to the 0.043 times 5 equals y. How many should there be? And that's actually just the calculation now. So that's a pretty simple question. What's more difficult is if they'd asked us, how long will it take for this population to double? And what we'd do is the same thing. We'd like we did before. Say we started with 83. If we wanted it to double, that would be 166 equals 83 e to the 0.043 t. And then we'd have to solve for t like we did before. And the last thing you need to know is that, for example, in this one, if it starts, the population in 2010 is this, we're going to make y sub 0 we're going to make y sub 0 the population in 2010. And if we want to know what's the population in 2025, we're going to make t equals 15, because it's 15 years from 2010 to 2025. And that's all you need to know. Good luck, everybody.